Okay, lecture 22. Makeups. Do we have Janet tomorrow? Did you guys zero in or not?
We're going to do tomorrow at 10.
10? Where do you want to meet?
Do you want to Gary? I don't know what classes are.
Doesn't really matter to me. Are you down here on campus at 10?
Yeah.
We'll meet down here, Marshall, on a spot. Did you and Brittany split the dry matters last week?
Yes.
Okay. Review session today at 4. Is there any questions everybody wants me to address in that? Even if you can't make it, it could be recorded and posted later. Is there anything that you want me to address? Okay, so anybody planning on coming to that today at 4? Okay, we'll try to find a place in Marshall, and it'll also be on Teams. Thursday, we'll continue on with ration balancing and manure scoring and sieving. So we'll be out in the barns a little bit, so dress accordingly. Test on Wednesday. Probably finish up minerals today and then move on to vitamins. So we've got to make up, Josh. You got to make up your coster at some point. Do you have a preference on either of the 11th this week or 18th next week? Whatever works for you, so give that some thought. Lab practical at some point. So what do we know about our minerals so far? What do we know about calcium? The macro mineral. What else?
Percentage of the diet.
Is a percentage of a diet is macro? What was yours?
Daily.
Needs to be fed more or less daily, but we got that reserve in the bone that can be helpful to buffer a loss on a given day. What does it do in the body?
Muscle contractions.
Muscle contractions, necessary for muscle contractions. It is the catalyst that starts muscle contractions. What else?
Enzyme activation.
What?
Enzyme
activation. What else?
Blood tissue.
Certainly in the fluid, acid-base balance. What else? Bones. That's the big one we always fall back on. What do we know about our electrolytes? So potassium, sodium, and chloride. What do they do? So you've got extracellular, intracellular. They are the major electrolytes there. Their location helps the body maintain itself. So we put the potassium inside the cells, we have the sodium outside the cells. There's a natural tendency to them to want to get to the other place. The body uses that as a driving force and an electrical force that helps get things done. So last time we talked about iron and zinc. Any questions on those as micro minerals? So moving on to iodine. Iodine, you're pretty much going to find it associated with thyroxine. So thyroxine is manufactured in your thyroid gland, so most of the iodine will be stored there on the anticipation that you're going to make thyroxine. The rest, the thyroxine out in the body, that will be where the iodine is. It really only has one purpose. So we're talking very small amounts given in a day. You'll have trace mineral salt for our bovines is a good place to get that. You'll also, as humans, you have iodized salt as your source. So when we were having trouble with getting enough iodine in our diets, people said, you know, people use a lot of salt, let's put it in there. So iodized salt helps us prevent the problems associated with lack of iodine. So if we don't have enough iodine, we can't make thyroxine. Thyroxine is all about getting our basal metabolic rate up. So if we don't have thyroxine, we're going to have a slow or severely reduced basal metabolic rate. We're going to feel cold all the time. We're going to feel listless, tired, no energy whatsoever for that lack of iodine. There are other reasons you can feel that way as well, but that's where iodine fits in. And if we don't have enough iodine, we get a condition called goiter. Does anybody know what that is? It's a hypertrophy of the thyroid gland. So if we show a picture of that in a fetus, no iodine in the diet, this sheep starting to create or attempting to create thyroxine leads to a hypertrophy of that thyroid gland. So if we're dealing with a lack of iodine, what happens that leads to this condition? Is anybody familiar with the pituitary cascades that happen at the base of your head? So you'll certainly get into them in 110 if you haven't had them yet. We're talking about things starting in the hypothalamus, going to the pituitary, and then going to a target tissue. In the case of iodine, we're dealing with a hormone called TRH, TSH, and then thyroxine. So this is the hypothalamus. I'm striking out today. Hypothalamus at the base of the brain. That sends TRH, thyroxine releasing hormone or thyroid releasing hormone, to the pituitary, specifically the anterior pituitary, which is right at the base of the brain. It's a very short trip, less than an inch. Thyroid stimulating hormone is secreted next, and that target tissue is the thyroid. So we have, certainly in my family, we have some thyroid concerns. A number of people are having their thyroid adjusted. In a normal environment, the end product of this hormone cascade feeds back and provides a negative feedback. That if we've got enough thyroxine produced, we don't need to have the stimulation of that cascade going. Okay, everything's done. We shut this off until we need this again. So what happens with the goiter is you have this, but nothing here because you don't have the iodine to produce it. So you're going to lose the negative feedback. So what continues to happen?
It never stops.
It just keeps going more. Well, if we don't have enough thyroxine, I got to produce more. Stimulate more, stimulate more, stimulate more. And you get this big swelling of that organ because you never get the end product feeding back to shut it down. So the thyroid stimulating hormone is in excess. That organ swells, hypertrophies, trying to produce thyroxine, but you've got one of the main building blocks missing from that, so it never happens. So that tissue continues to grow, and we have what's called a goiter. And they can happen in anything. We certainly have a history in this country of happening to humans. And that's why we place the iodine in the salt on our table salt. So we make sure we get enough iodine in our diet to prevent that. So how did I gain all this? My metabolism has slowed down. Maybe I'm going to gain weight instead of burning it off. I have a goiter, iodine deficiency. How did you get those double chins? Selenium, next up. Any questions on iodine here? Selenium. You think about its function as an antioxidant. That's kind of an overarching thing there. So associated with glutathione peroxidase, that's an antioxidant function. We hear commercials all the time. It's like, I'm in control of my antioxidants and I feel great. So life is an oxidizing process. If we let that run rampant or we don't cancel that out in some way, we'll run into trouble. So selenium and vitamin E are involved in that. Selenium seems to be involved in the immune system being as strong as it could. So immune system responsiveness depends on the adequacy of selenium. This is one of the reasons we give that UC shot in the dry period. We want that immune system working the way it should so we can get through that calving and get that placenta out. So UC has selenium and vitamin E. It's associated with reproduction. And our highest concentrations are going to be in the organs, kidney, and the liver. It's where it's stored until it might be needed. So micro, so we're looking at probably milligrams per day. When we're getting our selenium, we're getting it from specific selenium supplements. They are added at the feed mill usually. The selenium has to be regulated because, as we said, there's that narrow band between what's healthy and excess. We need that very narrow window so it's controlled, it's regulated, so we don't overdo it. So if they're selling you a feed, they have to estimate how much grain that you are getting and then include that selenium at a rate that allows proper supplementation, but not overdoing it. So the specific selenium supplements, most of them are inorganic. There's been a lot of thoughts about making them organic in the sense that you can accumulate it in garlic and things like that. Those garlic supplements might be a way to better provide selenium to the animal as opposed to the inorganic supplements. Another concern we have with selenium is the soil. It can be a source that goes, soil gets absorbed into the plants, the selenium then fed to the animals. There are certain places in the country where we can overdo selenium just by eating the local forage. The Northeast is not one of them. We had the glaciers come through, and we are a selenium deficient area. but there are places out west where you're going to run into trouble. If we don't get that selenium at the proper levels, retained placentas will increase during calving. You have a problem called nutritional muscular dystrophy, or white muscle disease in lambs or calves. It's not the same as what we'd see in humans, but it's called the same thing or called by the same name. If we get into excess, we can have liver, one of the places it's stored, or pancreas damage. So we might have some issues with diabetes being a side effect of too much. So General Custer died of selenium toxicity. Has anybody heard this before? So I brought this up in a class, and a student went home, told their parents, and they called bullshit on me. So I actually had to look up the reference. So this is a paper put out by Skip Hitz. Dr. Hitz was at Cornell. So the Battle of Little Bighorn was fought over 100 years ago. So this is a 20-year-old paper. Fought over 100 years, many controversies remain. Some feel that the defeat of Custer could have been avoided if Petain and Reno, the two generals or majors underneath him, were united with Custer. The slow-moving pack train may have hindered the troops of Petain and Reno from joining up with Custer. So everything was horse-powered at that time. If the animals could not cover the ground that was necessary, that pack train fell behind. One report indicated that the horses and mules in the pack train were lame, so they couldn't walk, their feet were inflamed, and behaved crazily. It has previously suggested the animals had selenium toxicosis. That's the lameness issue. We propose the lameness could have been caused by selenium, but the behavioral problems may have been caused by the ingestion of plants containing swansonine. So nutrition influencing history. If you take a look at this map, where are we going to find our places of selenium deficiency and selenium adequate? And then we have variable depending on where we are. So as said, the Northeast, this area tends to be low. That's a function of the glaciers coming through and clearing everything off. So you got some glaciation down there. I'm not really sure why geologically we're there. The central plains, we have areas that are adequate, and we run into areas here that are variable. So that's by state. If we get down to smaller detail, so not just by state, we've got areas that light blue here is low selenium, and then our black dots, we may have areas where toxicity might be a problem. And with General Custer, his reinforcements that never showed were going through these areas of high toxicity. So we get laminitis if we have too much selenium, liver damage, inflammatory response. We get the lamina of the feet, the corium swelling up, possibly even popping the hoof off. And you can imagine if the animals are lame, they're not going to move that wagon train nearly as far as they could otherwise. So knowing where you are, do I have to worry about toxicity or do I have to worry about supplementing? In the Northeast, we have to worry about supplementing. So everybody follow the logic that General Custer died of selenium poisoning or selenium toxicity. It affected the animals moving through particular areas. And if you've ever been out there, there are some places where things are so arid that anything that does grow is probably going to be concentrated in minerals in some way, shape, or form. And if the animals are eating what's there along the way, they're going to get whatever minerals are ahead. So selenium ahead, cliff 500 feet. If I could just make it to better soil, I might be okay from a selenium basis. So lack of selenium, I've got bad liver function, so the yellow is what? Jaundice, associated with the malfunctioning liver, placenta. If we don't get enough selenium, copper. So we're sort of working down in the amounts here. Copper does a range of things, needed less than the other ones that we've discussed so far. So hemoglobin formation, copper is necessary. Hemoglobin is what carries the oxygen in the blood. Copper is necessary for the cytochromes that form the ATP. The last step in the formation of the ATP is the cytochromes. So if we don't have that, we're going to have trouble generating ATP. Copper is associated with elastin production. So the connective tissue that's got some spring to it, it's got some give to it. That connective tissue, a lot of that's found in our aorta, our arteries, particularly the aorta. Copper is necessary for melanin production, the color that we see. So black in our black and white Holsteins. We also need copper for proper bone formation, and that has to do with the amount of protein connective tissue in that bone. So copper is doing a lot of different things. We usually get our copper from our trace mineral salt. One of the concerns out there in the dairy industry is we're introducing a lot of copper onto our farms. Does anybody know why? So our foot baths, we're bringing in a lot of copper. We're importing it to our farms, and we're getting to the point now where it's like we might start getting into copper toxicity, and that might be an issue. With copper, we have to be careful with sheep. Can't overdo it with the sheep. We can feed a whole lot more copper to our dairy cows than we can with our sheep. So we have to make sure, like, we don't allow our sheep to get trace mineral blocks. That could be a problem. Or be feeding ruminant feed or feeding cow feed to sheep, especially if we've got the trace minerals in there. We may get into trouble by copper toxicity with our sheep. So not enough copper, we're looking at anemia. If you can't produce hemoglobin, you're not going to have enough oxygen carrying capacity. That lack of oxygen carrying capacity is called anemia. Cardiovascular rupture. That has to do with the lack of connective tissue, the lack of elastin. If those vessels are not springy anymore, they may tear in response to a heartbeat, especially an exaggerated or stepped up heartbeat or cardiac output. We also can lose color to the hair coats on our animals. So graying or loss of color. There are a lot of reasons for we might lose or gray things out, lose color, but one of them is copper. So it was kind of a fun thing. We went working on a farm, and one of the professors that went out there, he goes, "Oh, the Holsteins are brown. That must be copper toxicity." And the farm manager just started laughing. So it's probably not what you'd expect, but It was more likely they were out in hutches, they were outside, that color got washed out in the summer sun. So lack of copper. If you don't have a lot of things working in that animal, you're going to reduce the growth rate. If you don't have enough oxygen because of anemia, the animal's not going to grow, it's going to waste away. So you're going to have animals that look really skinny and pretty sad in some way, shape, or form. Copper, didn't scan as well, but COPPER is in the shape of a bone. So remembering copper is included in bone formation. So copper, gray hair up top, elastic sweatpants on the bottom, and being physically fit, we got that copper where we need it to be. Oh no, I'm turning gray, lack of copper. Slight problem there with the udder in the back. The udder's coming out the side of the cow. So, but it's something we can remember. Make sure you get your copper intake every week. I wish I had luscious hair like you, so making sure that we get that color there. Cobalt. So the main function of cobalt is to be part of the vitamin B12. So again, we don't need a lot of that, but we need to provide cobalt to our dairy cattle so the microbes can make B12. If we don't have cobalt, that B12 doesn't get made. And we'll have the deficiencies associated with a lack of B12, which are the same as a lack of cobalt. So we don't have that essential building block. Cobalt will come organically from plants, absorbed by the plants and provided to the animal that way, or will provide inorganic salts in some way, shape, or form that will give those microbes the cobalt they need. Again, the glaciers came through. The soils in the Northeast tend to be lacking in cobalt. So most of our trace minerals. B12, we don't have enough of that. You're going to get a lack of appetite, anemia, sluggishness, a lack of thriftiness associated with that. So B12 deficiency. So cobalt, where are we going to find that? The blacker areas have lower concentrations. We've got medium there. We're in central New York. We're in that white area where we're not finding much of anything in our feed stuff. So we need to supplement that cobalt as a micronutrient, making sure that we have what we need. Simple difference in cobalt. One lamb from a litter got cobalt, one didn't. So anemia, lack of growth, lack of appetite, you're not going to grow. You don't have enough oxygen, calories, protein to get the job done. So you're starting to generate that runt look. Moving through. So if I have cobalt, I'm hungry, I'm not losing my appetite. Cobalt very much related to B12, so that intersection, one doesn't exist without the other. And we're getting into things that you'll never have to worry about from a production sense. Molybdenum. Just living on the planet, you're going to get more than enough. We require so little that it's almost impossible to have a deficiency of it. Just living on the planet, there's enough dirt contamination that you get it. In order to show that it's even required, it takes multiple generations of a molybdenum-free diet, and it's just not worth worrying about. So, can we really generate one? Is there a true thing like we have with calcium? We can make that deficiency happen very quickly. Lack of a better thing, we're just going to say poor growth associated with that. Manganese, again, just living on the planet, you're going to get enough manganese in your diet. Although, if you're willing to pay for it, I'm sure somebody will sell it to you. Cofactor and enzymes, you're going to get it just living on the planet, the diet. Lack of manganese, it will lead to impaired growth, skeletal abnormalities, poor reproduction, birth defects. So, kind of non-specific in some sense, but showing that it is essential to make things happen. But again, there's no practical significance about worrying about manganese. That cutoff line was about cobalt. Well, everything before that, we need to make sure we get taken care of. That's as simple as providing a trace mineral salt, and then that gets us up to our macro minerals, and we balance for those as we go through. So manganese, so kind of a mini-me thing happening. It's a little defective in some way, shape, or form. So Mn in there, we have some growth problems, possibly a manganese deficiency. Man your knees. I have a structural abnormality. My knees don't look like they're supposed to. Manganese. So manganese. Remembering that there's a problem. Chromium. This is something probably about 20 years ago people were hot on because it appeared to be related to immune function. Hey, if I'm deficient in chromium, my immune system is not going to work the way it's supposed to. Therefore, for a while there, you saw it in cold remedies and things like that. Hopefully, you can fight off colds, flu a whole lot better. But again, you're dealing with such small amounts that are required. There's really no reason to think about supplementing extra, because if you supplement it, what's the problem you're going to run into? Too much and the damage that too much might cause. So with our minerals, we're trying for that Goldilocks space. Not too much, not too little. Our minerals, we tend to see toxicity a whole lot faster than some of our other nutrients. So we're looking at very vague, specific functions with manganese, molybdenum, chromium. We get them all from the diet, just normal contamination. There's more than enough there. We need so little to get through. But for a while there was a hot discussion about how that was there. Fluoride's another question, fluorine, a question mark. Usually people are more concerned about excess here and the bad things excess can do. Trace amounts seem to help with the bones in the teeth, make them stronger. Fluoride treatments seem to make your teeth last a little bit longer. Again, diet usually takes care of that. So little is possibly necessary. that it's hard to generate a fluorine-free diet. Just rolling around the dirt, you probably get all you need. With fluorine, the excess is the concern. On livestock production, this is where we've run into trouble so far. Being downwind from a nuclear power plant, those pastures seem to get a lot of fluorine added to them, and our cows tend to get overdosed and their bad things happen to their teeth in some way, shape, or form. So fluorine, fluoride, gonna help my teeth, help my bones. Good for teeth formation and protecting our teeth from problems. But too much can cause a problem. So too much swag, too much bling on my teeth, too much Florida on my teeth is going to cause some problems. So finding that sweet spot where we're getting enough but not too much is where we're shooting for. Making our teeth strong at the dentist. Then there's a lot of things that might fall into the questionable thing. Are they required or not? So taking that criteria for essentiality and putting it through the test. Is removing these completely from the animal, from the diet, does that cause problems? So the hard thing is to actually get all the arsenic, all the aluminum, all the nickel, silicate, tin, any of those, removing them from the body. You're going to get a certain amount from your mom. So in order to make the animal free of these compounds and some of the other ones we just talked about, you're talking about multiple generations of a purified diet. And there are other problems associated, particularly when you're dealing with ruminants, of a purified diet. So I know I was involved in mixing the diets for a pregnancy study related to copper and zinc. That was one of my jobs on the weekend. I'd come in and do what needed to be done with the animals, take care of them, mix up their diets, bring more hay in, bed them up, clean the barns, whatever needed to be done on the weekends. But their purified diet that had no copper and no zinc didn't have any forage in it. They got their NDF by sulfaflock. It's basically this powdered form of NDF. So these poor sheep didn't have any scratch factor at all. So they were looking for something, anything they could chew on, just to get the feel of ruminating, and because their diet wasn't stimulating it. So generating a diet that's free of these, generating a body that's free of these takes forever. And what really gain are you going to get? Nobody's going to say, hey, I've got a new arsenic supplement here for your cows. Just not. That's just not going to happen. So some things we need to worry about from a toxicity standpoint, the ones that we run into trouble. Cadmium, fluorine, lead, mercury can all lead to severe problems when they are present in excess. So a mixing error at the mill where you've got the wrong thing going in the wrong vat, or just the contaminants in the environment, or the excess finding its way into the water and feed associated with the animals. So I'm going to stop there. I have your first tests graded and logged and all that stuff. What I'd like you to do is we'll pick them up here real quick. Check the math. You can see if there's any questions, and I'd like to talk about how your grades are calculated in this class. So,
Are we giving back the test after?
nope. I've got everything off that I need. One of the big concerns for why things were marked wrong, I tried to note where it did, is you didn't answer the question. So one of the downsides about looking at old tests is there may be a similar wording to a point, but then it changes. So there's some issues there. So take the time to read the question and try to provide what it's asking for. So there's a lot of different ways to ask things. So what I do on the tests is I go through and grade questions one at a time or in sets, depending on how related they are. I total up at the bottom right-hand corner underneath a line. So you'll see something like this down in the, you got the corner, this isn't my day, right? So corner of each page, there's a line here and then there's a number underneath it. Those are the points you got for that page. I take those points, I add them up in a spreadsheet, and that generates the score that you have written on the back of the test. So please go through and make sure you check the math, make sure everything's where it's supposed to be. So we've got these tests up front. They're in no particular order. Come up and pick up your test. Everybody got a test that wants one. So I will fix math errors, points errors for free. If you have a complaint about the way something was graded, don't agree with the points you were offered, you think needs something to be a change, you need to submit your whole test back along with an explanation. Page 3, the question related to this. I would like you to regrade it. This is what I was doing. That's what I was trying to achieve in some way. And this is why I disagree with the grade I received. So I will listen to your concerns, but if you turn something in like that for regrading, I reserve the right to regrade the whole exam. So I want to, a lot of you may not have the grades that you're happy with, but I want to show you something that I'll get posted up on Blackboard. So I have, based on how we're doing stuff in this class, an opportunity to project your grade. So this is the percents associated with each point here. So exam 1 is worth 12% of your final grade. You can get a 50 on it and still get an A in the class. So you can do very poorly and still do very well. These are the ones I want to call your attention to. The quizzes, if you're showing up, taking the quizzes, usually by the end of the semester, everybody gets 9 out of 10 points associated with the quizzes. I'm dropping half of them. The point of the quizzes is I'm trying to teach you what I find important this time around, what the questions might be that I'll use on the exam. So most everybody gets 9 out of 10 there, especially if we do the attendance quizzes and things like that. Assignment. Your job is to turn them in. So we're probably going to have about 30 assignments before everything's all done. Turning them in on time, make an attempt to complete them. I don't care if they're right. It's more about whether you did it or not, and you're learning from your mistakes. So if you turn in all your assignments, that's 30% of your grade. You'll get all 30 points. Let's say you've got 27 out of 30. You got 90% of those assignments turned in. Participation, you show up, get to class, show up. So you've got .48 points. You've got 44 of those. And then for the exams. So what do I need to average on these exams over here to get a passing grade? So if I said we did a 50 on the first exam, that's going to give you 6 points. .70 average, you'll go probably pass the class. If you do your work, show up, which most everybody here is doing. So 75, and the grading scale is a C. That gives you D in the class. If I can go through, average 80 on these, it's pretty realistic. Something missing here. So I'm going to post this. I think there's something wrong with it, but you can do pretty well here if you make sure you attend class, take the quizzes, turn in all your assignments. That's going to be a significant part of your final grade. So that first test is not so critical. You've got another one on Wednesday. You got your feed ID coming up. You got your lab practical and your exam 3 after break. So there's an opportunity here as you get toward the end of the semester to finish up strong. You finish up strong, we take that into account and move through. Any questions on any of that? So take a look over. There's a lot of people, and I tried to underline, if you didn't answer the question the way I was hoping you would, the part you might have missed.
If we have an extra credit slip, can we turn that in after the questions?
You can turn it all the way up till when I turn grades in. So if you want to do it next class, that's fine. If you want to do it finals week, that's fine. Whichever test you want to put it on, that's fine. Other questions? Okay, thank you for your patience. I'll get this fixed and posted.
Does the 927 and 8 have to be in the actual percentage form?
The what?
The 9 doesn't have to be 90 instead of 9.
No, you're entering out of 10 points. So follow the instructions over here.
I was just trying to figure out why it was still low.
I assume I messed something up. I'll fix it. So. I entered it wrong. There we go.